Hey look, it's PaperCam, Wave of the Future. Today we're going to see what we can learn from adding fractions wrong, right? So when you add fractions, let's have like denominators for now. What you're supposed to do is keep the denominator the same and add the numerators. But when you're first starting out, or young students, whatever, you'll sometimes do it wrong, right? And you'll just add across the top and the bottom. So you'll go 1 plus 1 is 2, 2 plus 2 is 4. So let's put a little dot, well, let's put a little X above the equal sign just to remind ourselves like this is not actually true. We're just kind of writing something that someone might write. Okay? So 1 half plus 1 half, this is not really that. Let's do a couple of them. I'm going to keep ones on the top for the moment just to help us see if there's a pattern. 2 sixths. Yeah, let's skip 4. 1/5 plus 1/5. Little x. 2 tenths. So are you noticing what I'm noticing? I guess I have to tell you what I'm noticing to see if they match. I see that this equals that, and this equals that, and this equals that. 2/4 equals 1 half, 2/6 equals 1/3, and 2/10. So when you add a fraction to itself wrong, it looks like it just gives you itself back. So let's see, is this always true? So what we can do is now we're going to go back to, well, no we're not. I was going to say we're going to go back to real addition, but we have to do the fake one with the little x over it. So if I do this, I get a plus a over b plus b. And another way to write that would be 2a over 2b. And then that's really like saying 1 times a over b. So it's a over b. So look, when we add the fractions wrong, we get the thing we're adding comes out. It's going to come out every time that way. What if I add it more than once? So I'll have 3a over 3b. And I see that the same thing's going to happen again. But what I'm going to end up doing, so if what is essentially happening if I add a fraction to itself a number of times, I just multiply it. So if I add it to itself once, I get 2 times that, 2 over 2 times that thing, 3 over 3 times that thing. What I'm doing is I'm just writing it in different terms. So that's mildly interesting. But what if I throw something strange at it, like 1 half plus 1/5? And I add these, and I get 2/7. Let's not forget to put that there. Am I going to see a pattern with this? 2/3 plus 1/5. 3 over 8. Just adding these, just doing it wrong on purpose. Let's do one more. 1/4 plus 2/5. 3/9. So, I don't know about you, but I think it would be very hard to suss out what the relationship of this might be to the real answer. We didn't actually do that up here, but it turns out it's half of the answer here. Always half of the answer. Try to figure out why that's true. So, but let's focus in on this one now. So I'm going to do the same thing and try to figure out just abstractly. So let's say I do a over b plus c over d. If I do it the fake way, I'll get a plus c over b plus d. Let's compare that with the way you're supposed to do it. So back to a over b plus c over d. We need like denominators. I don't know what these are, so I'm just going to multiply this side times d over d, right? So I have a db in the denominator, and then I'm going to multiply this side times b over b. So I also have a db in the denominator. So now we have like denominators. I can add. So I've got db, and then I have dA plus cb. Now I can look at these two and I can sort of think, so this is the real answer, this is the fake answer. What's the relationship between these two things? Sometimes just writing things a different way can help. So let's see, a over b plus d plus c over b plus d. Take a look again now. We could do the same thing over here, just break it up. dA over dB, well, we already had that over there, but let's just try it anyway. It'll be underneath this. CB over dB. So I'm looking at this, and the question that's coming to my mind is, well, what's the relationship between these two things? Do we know any relationship between d times b and d plus b just by looking at them? Let's see. b plus d. And then I'll just put like a box, like what's the relationship between that and b times d? This might be a good point to pause and think a little bit. But this is my idea. I'm seeing b plus d. Let's just kind of pretend we know what they are. And I'll say this is b, right? And I'll say this is d. So I'm going to assume, just to see if I can get any insight out of this, that these are positive numbers. So this would be b plus d. And, you know, we don't know how much this really is. It takes up 3 boxes on the graph paper, but we don't know how much it really is. And then I'm just going to take b over here and turn it. Hopefully I said b. Because this here is b times d. Just give a little shading. And this here is b. If I take this and add it to this, that would be b plus d. Now I'm getting this idea. What if I push those inside? So now I have d here, and I have b here, and this whole shape is b times d. I'll put a little weird bracket here. B times d. I don't know where this is going. So sometimes when you're exploring math, you're just trying to see where things lead, what things mean. This may not lead us back into seeing any clear relationship between the wrong way of doing it and the right one. It does lead us to one here. We can see, oh, you're just cooking up ways, other ways to express this quantity. But here, maybe we'll discover there's nothing. Or we might find something out about these that we didn't know. I don't think I've really ever thought of, like, in the abstract, what is the relationship between adding two numbers and multiplying them? And so right here, it seems like we're kind of seeing one. So if I take, so this spot right here is b plus d, but we don't want to count this twice, this little spot here, because it's part of d and it's part of b. So if we count it twice, then we won't be getting the right number. So that spot right there is b plus d minus 1. Right? Let's actually even put brackets here so we're like taking 1 from there. This. And then here, what is this? Well, this is b minus 1 here, and this is d minus 1. So this box here is going to be b minus 1 times d minus 1. So it looks like we can say b times d equals, so that's this whole thing, and then I'm going to re-express what's inside, b plus d minus 1 plus this stuff, plus b minus 1 d minus 1. Okay, let's work this out. Maybe we'll get some insight. b times d equals b plus d minus 1 plus good old FOIL bd minus d minus b, and then two negatives plus 1. So look what happened. Here's b, but here's minus b, so they'll go away. Here's d, here's minus d, those go away. There's minus 1 and 1, those go away. So what am I left with? b times d equals b times d. Voila! What does this tell me? I think what this tells me is this is all we know. There's no secret relationship between these two that we've not yet discovered. Because when we try to get in there and express it some other way, it just forces us back to here. Could be wrong about that, could be right. And maybe I've tried your patience because we're at 13 minutes, but this is the kind of thing you can do to learn about math.